This is Module 7.6, Electrolyser Daily Operations. You now have a background in electrolyser theory and familiarity with the electrolyser components and the safety equipment. Now, we'll look at the routine procedures. Arriving visual checks should be performed every time you go to the electrolyser. Before going to the balloon shed, give a visual check of the control alarm panel and the gas alarm panel to know what state the system is in. Is there power to the electrolyser? If not, you have to find out why before restoring power. Maybe there's a problem and the system shouldn't be started. Is the fire alarm indicator off? Is the rectifier on? If not, maybe it's something routine like it's windy enough to activate the wind switch. Maybe it wasn't started by the other technician due to a problem. Is the compression circuit light on? If not, that suggests something wrong with the compressor or the limit switches, and you have to exercise more caution when entering the balloon shed until you can determine the reason for the problem. Is the room temperature above freezing? If not, then you have to find out why before damage results from freezing the water in the electrolyser. Once you're satisfied that the control panel is okay, look at the gas alarm panel. Is the gas detector on? Is the needle showing 0% LEL? If not, advise the OIC immediately. Are the indicator lights for warning, alarm, and fail all off? As you approach the building, you want to pay attention to conditions. Are the fire or gas indicator lights on? Is there any debris or bird droppings on the stairs or ramps that might leave a slip hazard? Is there any debris on or around the ramps that might pose a trip hazard and affect the balloon release? Is the wall vent free of obstructions? When entering the balloon shed, it's best to enter through the front door. From that location, you can see all the cells and controls and can ensure everything is okay before you enter the room. The metal components on the front door are grounded, so as soon as you open the door, you should automatically become grounded as well. Before entering the room, a glance will confirm that no big puddles are underneath the cells as if the contents had leaked out. There are no fluids on the floor that might pose a slip hazard, and there's no smoke or strange odors. Then do a quick visual scan of the controls to inform yourself on the state of the electrolyser. You'll develop a routine of moving from one end to the other. Is the gas holder bell in an expected position? Are the 5 valves in their normal position? Are the manometer gauges normal? Are the cells showing normal levels of electrolyte? Does the current meter tell you if the electrolyser is in idle mode? Starting the electrolyser. The process of starting the electrolyser and putting it into production is usually performed in a circular trip around the electrolyser. First, check the fluid level in the cells and add water if necessary. This is usually a daily requirement. Then, refill the water reservoir for the next technician. Set the gas holder vent valve to vent. Set the compressor inlet valve to closed. Open then close the PDS valve to do a reset. Set the tank filling valve to open. Set the balloon filling valve to closed. The result of these steps is that all the valves are in their normal state except the 2 highlighted valves, and they'll prevent the compressor from running and the gas production will be vented outside until we confirm everything is okay. Check the fluid level in the gas holder and add water if necessary. It doesn't need topping up very often. Drain condensate from the Balston filter beside the compressor. Check the fluid level in the water seal and add water if necessary. It also doesn't need topping up very often. At the bottom of the hydrogen storage tank, remove any accumulated moisture. Depress the relief valve. A small squirt of hydrogen vented outside is sufficient. Then remove the cap and drain any water into the container. Now you've gone all around the electrolyser and are back in front of the rectifier. Adjust the current knob to 0. Push rectifier start. Adjust the current knob to 150 to 170 amps. The electrolyser is now running. But the gas holder vent valve is still on vent, so the gas is being vented outside, and the compressor inlet valve is still closed, so the compressor won't run. Before returning those valves to their normal configuration, we check the purity of the hydrogen gas to ensure it's not contaminated with air. The hydrogen purity test. We use the Pyrite sampler to test the purity of the hydrogen gas produced by the electrolyzer. When using the Pyrite sampler, you should wear safety glasses and gloves. Before using the sampler, we have to check the aspirator bulb to ensure it has no leaks. Put your finger over the tip and gently squeeze the aspirator bulb. It should remain firm. If it squishes, it means there's a leak between the aspirator bulb and the tip. Secondly, put your finger over the end. The aspirator bulb should squeeze down, but when you let it go, it should remain squeezed. If it inflates itself within 15 seconds, it means there's a leak between the end of the hose and the aspirator bulb. If there are any leaks in the aspirator bulb assembly, contact the OIC. After checking the aspirator bulb assembly, now we zero the sampler, making sure that it reads 0 before we introduce our gas sample. Push the plunger down to vent any pressure. Invert the sampler, letting all the fluid run to the bottom. Then turn it right side up, again letting all the fluid run to the bottom. Repeat that for a total of 4 times. Tilt the sampler 45 degrees to allow the fluid to settle at the bottom of the column. Push the plunger down again to vent any pressure. And then loosen the scale knob and adjust the scale so that the pointer reads 0. The Pyrite sampler is now 0. Now we measure the oxygen content in the hydrogen gas. Attach the end of the sampling hose to the sampling port. Open the hydrogen sampling valve. Squeeze the sampler bulb a few times to ensure the bulb and sampling assembly is full of hydrogen. Hold the sampler tip on top of the plunger and push the plunger down. Give the bulb 18 squeezes, letting the plunger back up on the 18th squeeze. Close the sampling valve. Invert the sampler, letting all the fluid run to the bottom. Then turn it right side up, again letting all the fluid run to the bottom. Repeat this for a total of 4 times. Tilt the sampler 45 degrees to allow the fluid to settle at the bottom of the column. Read the oxygen concentration against the scale. Normally, the oxygen content is close to 0%. If the oxygen content is greater than 0.5%, redo the test. After the second test, if the oxygen content is in the 0.5 to 1.0% range, the electrolyzer is still safe to operate, but you should advise the OIC. But after the second test, if the oxygen content is greater than 1%, shut down the electrolyzer and contact the OIC. If the oxygen content is acceptable, set the gas holder vent valve to gas holder and the compressor inlet valve to open. The gas being produced is now en route to the gas holder and the compressor inlet valve is open, allowing gas into the compressor as needed. Make appropriate entries in the electrolyzer log: the wall vent heater temperature, the oxygen content reading, the room temperature, and your initials. Departing visual checks are performed every time you leave the electrolyzer room. Before you leave, do a visual scan left to right across the front of the electrolyzer. Is the current set properly? Are the cell water fill valves all closed? Is the cell electrolyte level correct? Are the manometer gauges showing at least 1 inch between the inlet and outlet? Are all the valves in their normal position for production? To make it easier to do a visual check on the valves, yellow dots have been placed under all the valve handles. If the valve is in its normal position, the yellow dot is hidden, but if the valve is not in its normal position, the yellow dot is visible. So before going out the door, do you see any yellow dots? The demineralizer. If you've emptied the water jug filling up the electrolyzer reservoir, bring the empty jug to the operations building to be refilled. Open the water valve to start the water flowing through the demineralizer cartridge. While the water is flowing, test the cartridge by turning on the test meter. If the test meter reads in the red zone, contact the OIC for instructions on changing the cartridge. But if it's not in the red zone, adjust the rate of flow and put the hose in the mouth of the container. The maximum flow rate should be less than 500 milliliters per minute, or about a coffee mug's worth in 35 seconds. The standard 10-liter water container will fill in about 25 minutes. This concludes daily electrolyzer procedures.